Hello everyone and welcome back. In this video we'll be discussing about array indexing and slicing in Numpy. So let's begin. So I have already imported the library into our code. Now let's create an array by using the array method. And for that I'm going to type np.array and pass the elements in the form of a list. In this case I'm going to provide random elements, maybe like 12 elements randomly. For example 1 comma. And let me copy this array into a variable, for example arr, and run this cell, and let's see what is inside arr. So an array is created with 12 elements that we have provided randomly. Okay, so now what if I have to select this particular element, which is 12. Let's see what the index of 12 is. The index of the first element is 0, 1, 2, 3, 4. So 12 is in the fourth index. In order to access the fourth index element, I will have to just provide the variable name of the array, which is arr, then square bracket, and then provide the index, and run the cell, and we get access to the element in that particular index. If we provide arr, maybe another number, maybe like 10, and the element at the 10th index, which is 13, is provided. This is about selecting one particular element from the array. What if I want a series of elements or a range of elements from the original array? In order to access that, I'll have to provide the array name arr, then a square bracket, then the slice notation, which is the colon, and provide the start index in the beginning and end index next. So the start index in this case, let it be the beginning itself, so provide 0 as a start index, and if I want from the beginning up until maybe 12, so 12 is in the 0, 1, 2, 3, 4 fourth index, so I'll have to provide 5 because end index is not included. So the start index is provided and the end index will be actually the number provided here minus 1, which is 4. So when we run the cell, we get elements from 0, 0th index up until 5 minus 1, 4th index, which is 12. 0, 1, 2, 3, 4. 4th index is 12. Okay. Since we have begun from the 0th element, this line of code is exactly same as writing arr and not providing anything in the beginning and providing the end index, and run the cell, and we get the exact same output. This is because by default the start index is always 0. Okay, so what if I want to access the entire array? In order to do that, I could just type arr and square bracket, just a colon, and leave it as it is, and then just run the cell, and we get the entire array. That's because by default the start index is 0 and end index is the final index. Cool. If I provide any other start index other than the 0th index, for example in this case maybe arr square bracket, maybe from the 4th index, that is the element 12. Okay, so maybe provide 4 as the first index or the start index, and then colon, and then leave it as it is, and then just run the cell and see we have the entire array beginning from the 4th index, right? So the index of the last element should be 13 because we have like 12 elements. So this is exactly same as providing arr square bracket, start index is 4 and end index is 13, and run the cell, and we get the exact same output. Fine. So the next topic that we have to learn is about the third feature inside the square bracket, which is the step index, which is provided after the second colon as this. For example arr square bracket, specify maybe the beginning 0th index, then I want up until the last element, which is the 12th element 13. So and after the second colon provide the step index. In this case I'm gonna provide 1 and run the cell, and we get the exact same original array as arr. In this case the step index is 1, which means it is taking one step to the next element in the original array. What if I provide 2 here? It takes 2 steps to the next element. So 1 2, the next element is 4, and 1 2, the next element is 12, 1 2, the next element is 45, and so on. What if I provide 3 here? It takes 3 steps to the next element from the original array. So 1, the beginning, and then 1 2 3, next element is 6, 1 2 3, next element is 45, 1 2 3, next element is 43, 1 2. We don't have further steps, so the array ends here. So as you can see here, so that is about the step size. And if we provide the array without specifying anything other than the colon, like this, arr square bracket colon colon, and then run the cell, we get the exact original cell by the default value as the start index and the end index, and step size as 1. Okay, what if I provide arr square bracket colon colon and 2 alone, and we get the exact same output as this when we change the step index of this statement as 2 and run the cell, and we get the exact same output for these 2 lines of code. Now let us learn a new concept. Let's call the original array arr, and I'm going to slice this array maybe into first 4 elements or 5 elements. So in order to do that, I'm gonna do arr square bracket from 0th index up until 5th index. So I'll get 0 1 2 3 4 up until 4th index, which is element 12, 1 to 12. Okay, fine. I'm going to copy this into a new variable which is known as arr slice, maybe slice equal to this particular thing. I'm going to copy that and paste here and run the cell, and let's see what is inside arr slice. See, perfect. Okay, now what I'm going to do is I'm going to assign some or change the values of arr slice into different values. So maybe I'm going to access the first 3 elements in arr slice as arr slice square bracket, and from 1 2 and 4. Okay, so 0th element up until 4th element, maybe like, okay, up until 6. Okay, fine. And I'm gonna do something which is like this is equal to maybe 22, and run the cell and see what is inside arr slice. And as you can see, the first 4 elements inside the arr slice has changed into 22. Right, now let us call our original array once more and see what is inside arr, and see the original array arr has changed first 4 elements of it into 22 just by altering the slice which we have copied into a different variable. What actually happens here is, whenever I make a slice of the original array and I try to copy this into a new variable, it doesn't actually copies the value into a new variable. Instead, this actually serves as a reference to the original array. So whenever I make changes to the slice or the new variables, which is the reference of the original array, it changes the original array. So Numpy actually does this to deal with the memory issues when it comes to large numerical arrays. So if I want to not make any changes to the original array by altering the values inside the slice variables, I'll have to use the copy function just like this. So let the new variable be arr copy, and equal to the original array arr dot copy, and run the cell and see arr copy, and now arr copy is exactly equal to arr. And now if I make any changes to arr copy, for example, and let it be all equal to 22. Let's see what is arr copy now, and all values inside arr copy is 22. And let's see arr, and it has not made any changes to arr as of now. So that is all for this video. We'll learn about slicing and indexing of 2-dimensional arrays in the next video. Bye.